Today we will discuss the next topic in our robotics and its applications. And here we will cover the applications of robotics. So in the previous class, we studied about the applications in industrial sector. So how the robots are working and increasing the production and the profit in the industrial sector. Okay, now some other sectors, important sectors which the robots find its applications. Okay, so like one of the most important sector is the defense sector. So what is the main difference between industrial, the previous application of industrial sector and the defense sector? Okay, because in industrial sector, we studied about profit and how robots can increase in profit. Only then we will be using a robot in the industrial sector if we are having some profits. But in the defense sector, profit is not our main aim or the main target which we have to make. Okay, so the approach is different in defense sector. So robots in the military are an alternative to human soldiers. Okay, so our soldiers, safety of our soldiers, that is our main target. Okay, then these robots are being designed to handle a broader range of combat tasks, from picking off snipers to carrying out target acquisition with greater efficiency as compared to human soldiers. This performance should be better than human soldiers. So they can be deployed in situations and areas which are dangerous and can kill or harm the troops. Means our soldiers, they are at risk, they are in danger at some location. So there we can use our robots. The army robots can provide a fire and reduce the number of casualties. So here the safety, the protection that we are getting from the robot. So that is why we are using it in our defense sector. So they can also map a potentially large hostile area by accurately detecting a variety of threats. Okay, so how they are capable of doing it, we will be discussing in our coming lectures. The systems which are installed on the robot to detect its environment. Okay, next the military robots come in different shapes and sizes depending on the requirement, and they must be remotely controlled or fully autonomous. Then robot consists of different type of payloads depending on the application. So the requirements, sensors, detectors, weapons, then the program software and other payloads can be equipped on the robot used in the military. So here in these images we can get an idea how our robots are working in the defense sector. So that type of military robots, under this first type is like the intelligence, surveillance and reconnaissance. So ISR robot. So the armed forces can use small robots which can remain almost invisible to the enemy. So these robots help monitor enemy of forces or specific areas and send videos and images to the ground station with the assistance of GPS. Means the GPS technology can be used to get data or the transfer data from the area under surveillance, under monitoring to the ground station. So they can do such type of task of surveillance, of monitoring some type of area. Unmanned aerial vehicles are used for ISR operations to record potential target information that is difficult to detect. So next comes the research and rescue robots. Sorry, it is search and rescue robots. So search and rescue robots are highly advantageous in war. So how they can manage to search, track and rescue in unfavorable environmental conditions. So like the nuclear environment or the biological, some type of biological weapon is being spread there, some diseases spreading. Okay, so the robot, it can go through that. Similarly with the radiological or some chemical weapon is being used, then also the robots are immune to that chemicals. So they are getting, so that's the advantage above the human soldiers. So they can be used remotely, operated remotely by soldiers from a command center. Next type is combat support. So robots in the military are deployed in combat support application for anti-submarine operations. Okay, and laying mines and fire support, electronic warfare, battle damage management, strike missions, aerial refueling, and similar type of applications. So they also play a vital role in critical missions due to their enhanced capabilities and a certain degree of autonomy. So their capabilities, they are better, more than human being, and they're intelligent. So the autonomous means they don't need a human supervision at every instant or every moment. So the ability to achieve information superiority, minimize collateral damage, and fight effectively in urban areas against widely dispersed forces. The next is mine clearance. This is another application where army robots can be deployed. So they can detect and remove landmines and sea mines. So they should be equipped. So how, which type of equipments we are using, we will discuss it in our later units. So robot minimizes the risk of unexploded ordnance and other dangerous objects. So land robots, so very common for this type of application. Next is explosive ordnance disposal. So EOD. So these robots can identify some type of trap, then they can neutralize it, disarm it, means the effect, the dangerous effect it could cause, that could be neutralized by this type of robots. So some type of fireworks, some explosive devices, or some similar type of dangerous equipments or devices, they are being placed in some areas, buildings, vehicles, they can be detected by these robots. So they are integrated into bomb detection systems. So they can carry a variety of payloads depending on the EOD mission. So next is firefighting robots. So they can address fire situations and thereby minimize the casualties. The firefighting robots, they can detect the fire, implement a broad range of fire suppressing techniques, withstand high temperature for longer period. Big advantage we are getting here. Their body can withstand high temperature for a long time and respond to different types of movements. So these robots can detect fire. So because they're having suitable type of detection devices, the sensors, cameras, so through that they can detect the fire. So they can find their way through smoke and bring the fire under control. Next application of robots, that is in the sector of transportation. Just a minute, let me switch to the next slide. So new modes of transport using this robotics. So they are smart automated vehicles equipped with lasers, GPS, and other techniques capable of driving and flying themselves. Then automating transport aims to boost safety, reliability, and efficiency. Is using robots in transportation, that's safe, it's reliable, efficiency is also higher. So while demand will drop for drivers and pilots, so one side, okay, this could be a disadvantage that there will be drop in the demand for drivers and pilots, whereas demand in control and management will open up. So another sector is opening. However, for the full impact to be felt, infrastructure, regulations, and attitude will need to shift. Means we need some more arrangements to be done. The robotics market serving logistics and transportation companies is growing and rapidly it is growing. So distribution network across the entire global supply chain require a high volume of varied and complicated tasks. And a new technology is overcoming these obstacles in logistics in a few distinct ways. So here in this image, we can get an idea of the task this type of transportation robots are doing. Goods delivery also like that. Okay, now we can discuss them one by one. So container loading and unloading. So in the container loading and unloading, the variation in product size and shape was a big obstruction in an automated loading and unloading system. But in the recent advancement, so 3D laser vision, coupled with a new robotic software, they can view different products in a container, determine the optimal loading or unloading sequence, and carry out this function with a high level of accuracy. Next application could be stationary piece picking. So in a warehouse, items are constantly being sorted. So often it's simply a matter of moving a product from one box to another. Historically, piece picking has been difficult because robots weren't sure which item they were picking. So that could be right, that could be wrong item also. So industrial robot arms enabled by vision systems that can recognize which product is the specified product we want to pick. Okay, so they are able to handle this process in a stationary work cell. So this increases the efficiency and accuracy in this warehouse. Next is for the transportation sector, that robot buses. Then the green design and potential ability of the robots for long working hours. So these vehicles, or the vehicles actually, they are automated vehicles. So that's why they are robots. They give high efficiency and being green, eco-friendly. Okay, they are saving the environment, reducing the congestion by proper management, emissions, noise pollutions, and drive cost savings. It means much more effective in transportation sector. Next sector we shall cover, that is self-driving cars. Yes, so self-driving cars, so they are intelligent also, so having a good impact. So road safety, that is improved. Although the public is yet to be convinced that these machines are better drivers. Okay, means the current development, we need even more advancement in this sector, and the journey will be faster thanks to the machine enabled efficiency. Means the efficiency is higher, journey will be faster. New models of manufacturing will also be needed to build these types of cars. Means further we need more advancement in the sector, but this is an emerging field in the robotics applications. Okay, and this could be like in the long range driving, by human being driving for a very long distance, physical as well as mental fatigue that comes. So in case of intelligent autonomous car, that is a robot, this journey will be much easy, long journey. Then unpiloted planes for the air transport. So they are being used in the defense sector, just as we discussed. So it can be expanded to the commercial sectors for the passenger planes. Losing the pilot could save airlines massive amount of cash. Okay, this topic itself, okay, it is debatable. Well, we shall not be going to that topic in details. So, but the savings could not come only from moving the pilot, but also from the lower build cost as cockpit size that could be reduced. So this one is from the technical point of view, more size for the more space available for the passengers also. So much of the pilot's work is already automated. It's only takeoff and landing that will be needed from the manual point of view. Next sector could be automated trains. So driverless trains, because a large number of computers are there. traveling between different places. So unmanned metros are already boosting safety and enabling significant cost saving. So it is due to high efficiency and reduced labor cost in unmanned metro. With the metro train, so driverless metro. Then so they can schedule smoothly for a more reliable service, brake automatically for obstacles, and run for a long time. So don't need to change the driver after some certain distance. So autonomous metros are already up and running, high speed across country trains, but are yet to set off driver free. Means on the metros we are working on this sector, but on the long distance trains we are not there. Presently we are not there, but in the future we will be having that as well. So taxi drones, another application. So the impact of these robots, air taxis transport would be significant. Sending our everyday commute skyward could solve traffic problems in major cities. But that is the future of transportation. Already we have seen such type of imagination in various future movies. As they are noise and pollution free, the environment will also be benefited. So coming to the next sector, the robots in healthcare. So the healthcare industry uses four types of robots to improve the current standard of care, while also helping human to do things that they may not be able to do in the past. Okay, with have more speed and less errors. So we can see which type of task we are able to perform using a robot in the healthcare sector. So machines don't need to sleep. Okay, don't need food, don't have prejudices, and definitely won't grunt about why they need to complete the same monotonous task for the thousand time. Means repeatability that is very high. Robot mental fatigue is not there. Okay, some example in the healthcare sector is like the cleaning, the washing up of the hospital floor. Okay, efficiently they can do. Bringing medicine up to the 10th floor. These type of applications very effectively these robots can deal with. So we could imagine how healthcare robots could take over administrative or monotonous tasks that people like to skip away. Okay, while medical professionals, doctors, and nurses can truly devote their precious time to the job they are signed for. That is for taking care of the patients. So that can relieve these healthcare workers of the stress, and that will further benefit the patients. So in this image, we can see different type of tasks performed by the robots from nursing to surgery. Although for the surgery sector, we need much more advancement, more precise operation, but for the robot and nurses, very much practicable with the current configuration we are having, the current type of robots which we are having. Effectively, they can do the task of nursing. Now discussing these type of robots one by one. So coming to the surgical robots. So the procedure volumes of robot surgical procedures within the healthcare industry, that is a growing sector. So this is due to the adoption rate of the robotic surgical systems all over the world. So the robotic surgery allows surgeons to perform complex surgical tasks through tiny incisions using robotic technology. Surgical robots, self-powered computer-controlled devices that can be programmed to aid in the positioning and manipulation of surgical instruments. Next type of application is the exoskeleton. So robots can aid recovery and assist with surgery. Okay, that is one application. The robots can use sensors placed on the skin to detect small electrical signal in the patient's body and respond with movement at the joint. They're designed to assist patients rehabilitate from conditions leading to lower limb disorders. Okay, like we can say if a person is not able to walk due to some medical problem. So there is an exoskeleton. Exoskeleton means a supporting robot structure, like where like I can say that limbs supporting legs. So the human legs, they are grasped by the exoskeleton legs. Okay, and that exoskeleton is moving now. Means it is like a skeleton. Skeleton, we understand the word. So it is like a skeleton. It is holding the legs of the patient, and patient want to move. So these robot legs, they are moving. Through that, the robot is the human being, the patient, that is, he is able to move, commute from one place to another. Not long distance, but up to some distance he can move. So, so this application, so it includes exoskeleton, that includes biofeedback, waistband, lumbar support for airport and warehouse workers. Another application of the exoskeletons. So advance in brain machine connectivity will impact the evolution of exoskeleton. Means the thinking, what the person is having in his brain, that can be understood by the exoskeleton. Because exoskeleton itself is an intelligent robot. It can take the input data from the human brain. A care robot, a very common application. The number of robots used to provide care and support to elderly and disabled patients, so increasing significantly. The initial use cases for these products are relatively simple. So like helping people get into and out of the bed. Okay, but they will, so they will increasingly be called upon to perform more complex tasks, from reminding patients when to take medication, like nursing, like a nurse, private nurse. The robot is serving the patient, to provide emotional support and interaction for those lacking regular human contact. The patient, he's not feeling alone, no, not lonely. The robot is there to interact. So another expected use case for care robot is to assist nurses with a multitude of tasks that they perform on an hourly basis. Hospital robots, they can be used to deliver medications, laboratory specimens, or other sensitive material within a hospital environment. Robots, they can navigate using a built-in map. There's a map that is being built in the memory, the robot's memory. So that is actually artificial or the computer-like memory. So it uses Wi-Fi to communicate with elevators, automatic doors, fire alarms. So the robots have been designed to disinfect hospital devices and equipments. Several type of tasks which are related in a hospital, which are there, and the robots can perform. Now another sector, that is space exploration. So with the human being, if we are sending a human being into the space, first of all, we need to worry about his return path, the environment, the space, that may not be so much friendly to the human body. The temperature, the gravity there, the pressure there, radiation could be there. So robot's body can tolerate high temperature as well, high pressure, atmospheric pressure as well. Okay, so these are the advantages they are having above on the as compared with the human astronaut. Okay, so we need the robots to stick around long enough to investigate and send us information about their destination in the space where the robot is going. Okay, but even if a robot mission fails, the human involved in the mission, they stay safe. Because in the vulnerable area, the robot is covering that. Sending a robot to space is also much cheaper than sending a human. Because robots, they don't need to eat or sleep. So they can survive for many years. Okay, and we are also not much worried about the return. So also robots can do a lot of things that human can't. Like the harsh conditions, which I just addressed. These images show some type of task which a robot can do in the space. The role of robotics in space exploration has been significant due to the uninhabitable conditions of non-terrestrial planets in the solar system. For space exploration, a robot needed is a self-controlled device consisting of electrical, or mechanical units that can function in place of a living agent. So as robotic technology has improved, more of these experiments and tasks have been delegated to robots rather than to living beings. So that is in turn saving the lives of the astronauts or the human life. So space robots take measurements for astronauts. They can collect samples, they assemble and fix equipments and structures. The robotic spacecraft, that is an uncrewed spacecraft, usually under tele-robotic control. So a robotic spacecraft designed to make scientific research measurements is often called a space robot. So spacecraft, robotic spacecraft. So it can make the scientific research measurements. So many space missions are more suited to tele-robot rather than crewed operation due to lower cost and lower risk factor. So two type of advantages we are getting here. In addition, some planetary destinations such as Venus or the vicinity of Jupiter are too hostile for human survival. Okay, so there also robot is much successful. Outer planets such as Saturn, Uranus, Neptune, they are too distant to reach with current crewed spacecraft technology. So there also we can reach to large distance we can cover using this tele-robotic technology. So many artificial satellites are robot spacecraft, as are many landers and rovers. Now we shall come to the next application, that is the entertainment sector. So here we can see robots are finding application in a large or in a variety of sectors, from industrial, okay, like some from the profit point of view, safety point of view, important or the mandatory requirement of robots, like the saving of lives. Now coming to the entertainment sector as well. There also robots are finding use. So entertainment robot is made up of the sole subjective pleasure of the human. Because entertainment, just a human should give pleasure to the human. So it is not something like for a utility use. Okay, so as in production or domestic services. So robotic technologies are applied in many areas of culture and entertainment. From utility point of view, we are not using entertainment robots. So expensive robotics are applied to the creation of narrative environments in commercial venues, where servo motors, pneumatics, and hydraulic actuators are used to create movement with often pre-programmed responsive behaviors, such as in Disneyland's haunted house ride. So some type of an application of a automated entertainment uh, in system using robots. Entertainment robots can also be seen in the context of media arts, where artists have been employing advanced technology to create environments and artistic expressions, also utilizing the actuators and sensors to allow their robots to react and change in the relation to the viewers. This total environment we can create. Disneyland, okay, we can create haunted environment that we can create artificially. So there we use this type of entertainment robots. Image here we can see pets are there, doll, toys, different type of entertainment robots. So toy robot, so it is relatively cheap, mass-produced entertainment robot that uses mechanical. So they could be interactive. So they can do some tasks and tricks on the command, like we say our uh, pet pet robot. They come here, go there, jump here, so they can do such some common type of task. So they are capable of some features like the voice recognition or the walking. So entertainment robots, they can take the form of so they can take the form of I think the displays some issue with there.
Okay, so it can be some type of interactive communication, marketing tools. Okay, so at some type of a trade show, some exhibition, there we can use it. Now commercial show robots. So the robots are made for use as marketing tool. So logically showed up by the manufacturers to promote their products and technology. Something we can say it is related with the publication, publicity or the promotion of some product. Not getting this slide. Okay, anyways, so commercial or non-commercial type of application, some artistic type of environment, there we can use our robots. Okay, so the advantages which we are getting, so the entertainment industry is implementing robot for the same reasons. The manufacturers which are giving precise, repeatable, non-stop work. So those features make collaborative robots an attractive option in the range of entertainment industry applications. So robots are already appearing in applications such as entertainment arenas, interactive point of purchase sites. Like a common example, we can say if there is some exhibition, and in that exhibition, different stalls are there from different suppliers, different business organizations. And everyone is trying to grab the attention of the visitors there in the exhibition or some type of fair is there. So visitors are there and everyone is trying to grab their attention, market their product. So they're using different type of schemes to grab their attention. So their entertainment robot can be used. It is doing some type of entertainment activity and it is grabbing the attention of the visitors. So in that way, they can use it for the commercial purposes. So advantages like the space saving, lightweight design, flexibility, easy programming, short setup time, reusable program, fastback with none of the traditional robot cost for programming. Is cost effective as well. So different type of advantages we are getting.